All right, welcome back. Today, we are diving headfirst into a really fascinating piece of tech. I mean, this is the kind of stuff that's going to power the next wave of real-time applications. We're talking about the DeMoD communications framework, or let's just call it DCF.
So let me just start by asking you a question. Think about real-time online gaming for a second, or all those IoT devices you've got in your home, or even super complex edge networking. What do all these things really have in common? What's that one critical thread that ties them all together? Well, the answer is actually pretty simple, but the challenge behind it is it's huge. They all need to exchange data, and they need to do it instantly. I'm not talking about a few seconds of lag here. That's an eternity. For these things to work, we're talking about communication in milliseconds or even faster. And that is where things start to get really, really interesting.
So, how do you even solve this fundamental need for both speed and reliability? Well, the answer lies right here, in the framework that's at the heart of our explainer today, the DeMoD Communications Framework. So, what is DCF really? Well, it's a free and open source software framework, and that FOSS part is absolutely key. If you're a developer, that means you can get right in there under the hood and see how it all works. And if you're an investor, that should be a huge green flag. It signals massive potential for community adoption. The whole point of DCF is to make data exchange just incredibly fast, totally modular, and able to work with pretty much anything.
Okay, let's break down its core pillars, because this is where you really see its power. First up, low latency. We're talking sub-millisecond exchanges here. That is just exceptionally fast. Second, it's modular. And you should really think of this like building with Legos. You can just snap components in and out without having to tear down the whole thing. Third, it's interoperable. This thing speaks a ton of different programming languages and works on basically any platform you can think of. And finally, it's open source, GPL 3.0, which is all about transparency and letting the community drive it forward. All right, so DCF makes some pretty big promises: world-class speed, total flexibility. But how does it actually pull it off? Let's pop the hood and really take a look at the engine that's powering this whole thing. Okay, so the first key ingredient here is a technology that actually comes from Google called ProtoBuffers, or just ProtoBuff. The simplest way to think about it is this. It's a super efficient way to package up data before you send it over a network. It basically defines the structure of your data and then shrinks it down into this really compact binary format. And there's a quote from the source material that just nails it. It says, "ProtoBuff is like JSON, except it's smaller and faster." I mean, for any developer listening who's ever worked with data transfer, that one line tells you everything. You immediately get what a huge performance advantage that is. So just how much smaller are we talking about here? Well, the framework's documentation points to a data size reduction of around 50%. 50% compared to something super common like JSON. I mean, in the world of low-latency communication, cutting your data payload in half, that's not just a small gain, that is a massive win. So ProtoBuff is the super efficient data format, right? But DCF uses it inside another really powerful tool called gRPC. A good way to think about it is, gRPC is the high-speed highway that these little ProtoBuff data packets are racing down. It's this modern, open-source framework that lets services talk to each other incredibly efficiently. And it's built to scale up to literally millions of calls per second. Okay, here's another huge reason for DCF speed. It's handshakeless design. It's kind of like two people meeting for the first time, but instead of doing the whole, "Hello, how are you, nice to meet you" thing, they just immediately start sharing the critical information they need to. By cutting out that whole negotiation phase, you shave off precious milliseconds, and that makes all the difference. So let's see how this all clicks together inside the framework's architecture. It's really elegant, broken down into 4 clean, modular parts. First, the configuration module boots up and loads all the settings. Then, the serialization module jumps in and uses ProtoBuff to package up the data. Next, the networking module takes over and handles the actual transport. And the whole time, this crucial redundancy module is just sitting there, constantly watching the network's health, ready to jump in the second something goes wrong. So okay, we've seen how it works under the hood. But honestly, the why behind some of DCF's design choices is just as important, if not more so. These aren't just random technical features. They're incredibly smart, strategic decisions, and they have huge implications for both developers and the businesses they work for.
And a perfect example of this is its self-healing peer-to-peer networking. Look, this is not a fragile system. It is actively maintaining 2, maybe 3 backup connections for every single peer in the network. It's constantly sending out these little heartbeats to check if its friends are still online. And if a node suddenly just disappears, it dynamically and automatically reroutes all the traffic. I mean, for anyone building an application that absolutely cannot afford to go down, this is a total game changer.
All right, next up is something that is a massive selling point for any development team out there. Whether you're a huge company or a tiny startup, DCF is truly language agnostic.
And I mean, just look at this list. We're talking Perl, Python, Go, and Rust for your backend servers, C and C++ for your really high-performance stuff and tiny embedded devices, JavaScript for web services. You've even got Java and Kotlin for Android and Swift for iOS. It's just incredible. This level of interoperability is what lets development teams use the absolute best tool for the job without ever being locked into a single ecosystem.
Okay. Now for a design choice that, at first glance, might make you kind of raise an eyebrow. DCF intentionally, and I mean intentionally, avoids having its own built-in encryption.
And I know what you're thinking. Wait, isn't that a massive security flaw? But hold on, because it's actually a brilliant strategic move. For 2 big reasons. First, by not having certain types of encryption baked in, the framework is completely export control-free. That means it can be distributed and used anywhere in the world, no navigating complex US regulations. And second, it gives developers total flexibility. Instead of being forced to use one specific type of security, you can just layer on your own preferred solution, like TLS, and tailor it perfectly to whatever your project needs.
So it's pretty clear this framework is powerful today, but what about tomorrow or next year? Well, this is where DCF really shows that it was designed from the ground up to be built to last.
And the key to that longevity is its really powerful plug-in system. This means developers can add entirely new modules. Maybe you invent a new way to serialize data, or you come up with a different self-healing logic. You can even integrate brand new communication protocols as they're created in the future. The most important part here is that you can extend and enhance DCF's capabilities without ever touching the core code. That's what ensures it can adapt to whatever wild technology comes next.
Okay, so let's boil all of this down. What are the key takeaways here? Well, if you're a developer, the bottom line is this. DCF is a powerful, flexible, open-source toolkit that just lets you build faster and more resilient applications, period. And if you're an investor, what you should be seeing here is a scalable, globally accessible technology with just enormous potential for community adoption and innovation. It's an incredibly solid foundation to build on.
And that really brings us to our final thought for today. You know, when you have a framework that is this fast, this resilient, and this interoperable, it really makes you wonder, right? What are people going to build with this thing? What new, incredible applications suddenly become possible when data can move instantly and seamlessly between any device, anywhere in the world? And that's the question that DCF really leaves us with.